The event horizon of TON 618 is larger than the orbit of Neptune around our Sun. Let that sink in for a moment. This isn't a galaxy. It's not a star cluster. It's a single object, a supermassive black hole so vast that if you placed it at the center of our solar system, it would swallow every planet we know, and the boundary of no return would still stretch far beyond where Pluto orbits today. Its mass is roughly 66 billion times that of our Sun. To understand something this size, we need to leave Earth behind completely. So let's begin the journey, starting right here at home. To reach TON 618, we first have to leave our own solar system behind. The edge isn't where the planets end. It's much farther out, at a region called the heliopause, where the Sun's solar wind finally loses its power against interstellar space. Voyager 1, the fastest object humanity has ever launched, took 35 years just to get there. And even at that distance, we've barely left our own backyard. The nearest star beyond our Sun is over 4 light-years away. At the speed of light itself, it would still take us more than 4 years just to reach it. This is only the beginning of the scale we're about to face. Even after leaving our solar system behind, we're still nowhere close. Our entire galaxy, the Milky Way, is home to over 100 billion stars, and it takes light 100,000 years just to cross from one edge to the other. Our Sun is just one tiny point among billions, orbiting the galactic center along with everything else we can see in the night sky. If you shrank the Milky Way down to the size of a dinner plate, our entire solar system would be smaller than a single grain of salt. And TON 618 isn't even inside this galaxy. It's not even close. We're going to have to leave the Milky Way entirely. Zoom out far enough, and the Milky Way turns out to be just one member of a much larger family. We belong to what astronomers call the local group, a cluster of over 80 galaxies, all bound together by gravity. The largest of them, Andromeda, is so far away that its light takes 2.5 million years to reach us. That means the light hitting your eyes right now left Andromeda before modern humans even existed. Between these galaxies lies almost nothing, a void so empty that if you removed all the stars, you could travel for millions of years and encounter almost no matter at all. And we're still not even close to our destination. Zoom out even further, and galaxies themselves start to disappear into the pattern. Our local group is just a small part of something called the Virgo supercluster, a collection of over 100 galaxy groups spanning more than 110 million light-years across. But even that isn't the biggest structure we know of. Superclusters connect to form even larger formations called filaments, massive threads of galaxies stretching across the universe, separated by enormous voids of almost total emptiness. At this scale, individual stars, planets, even entire galaxies stop mattering. What we're looking at now is the actual skeleton of the universe itself. And TON 618 is waiting for us somewhere along one of these threads. So where exactly are we headed? If you could point a telescope at the night sky from Earth, TON 618 would appear in the direction of a small, faint constellation called Canes Venatici, the hunting dogs. It's not a bright or famous constellation. You won't find it without a star chart. But hidden within that unremarkable patch of sky lies one of the most extreme objects the universe has ever produced. From here, we're no longer just drifting through empty space.
we have a destination. And the closer we get, the stranger and more violent this journey is about to become.
TON 618 was first spotted back in 1957, cataloged simply as a faint blue star during a routine survey of the sky. For years, nobody suspected anything unusual about it. But in 1970, astronomers took a closer look and found something strange. Its light had a redshift far too extreme for an ordinary star. That meant it wasn't a star at all. It was billions of light years away, and whatever was producing that light had to be almost unimaginably powerful to still be visible from such a distance. What they had actually found was a quasar, the blazing, energetic heart of a galaxy, powered by something monstrous hiding at its center.
Once astronomers understood what they were looking at, the real question became, how massive does something have to be to shine this brightly from this far away? The answer was staggering. TON 618 is estimated to contain the mass of 66 billion suns. Not 66 billion stars, 66 billion times the mass of our entire sun compressed into a single object. To put that in perspective, our own galaxy's central black hole, Sagittarius A star, has a mass of about 4 million suns. TON 618 is over 16,000 times more massive than that. It's not just big, it sits near the theoretical upper limit of how massive a black hole is even thought to be able to get. Here's something that makes this journey even stranger. TON 618 is roughly 10.4 billion light years away from us. That means the light reaching our telescopes right now left that object 10.4 billion years ago, when the universe itself was less than a third of its current age. We're not just looking at a distant place, we're looking directly into the past. What we see today isn't necessarily what's there now. TON 618 could have changed, faded, or even stopped feeding entirely sometime over those billions of years, and we wouldn't know for billions more. Every glimpse of deep space is really a glimpse backward in time.
As we finally close in on TON 618, the first thing we notice isn't the black hole itself, it's what surrounds it. A massive, swirling disk of superheated gas and dust, called an accretion disk, spirals around the black hole at incredible speed. This disk is what actually makes TON 618 visible across billions of light years. It's not the black hole shining. Black holes emit no light at all. It's the material falling into it, compressed and heated to millions of degrees, releasing more energy than every star in an entire galaxy combined. We're not approaching darkness. We're approaching one of the brightest objects in the known universe. The numbers behind this disk are almost impossible to comprehend. Gas spiraling in the inner edge of the disk reaches temperatures of several 100,000 degrees, hot enough to strip atoms of their electrons entirely. It moves at a significant fraction of the speed of light, whipped around by gravity so intense that a single rotation can take mere minutes, despite the disk itself spanning distances larger than entire solar systems. As matter is compressed and heated to these extremes, it releases radiation across the entire spectrum, not just visible light, but X-rays and gamma rays, powerful enough to be detected from billions of light years away. This is what we call an active galactic nucleus at its most extreme. Now we cross into territory where the normal rules of physics start to bend, quite literally. As we move past the glowing disk and closer to the black hole itself, we enter what's called the photon sphere. This is the point where gravity becomes so strong that light itself is forced to travel in curved paths, sometimes even looping completely around the black hole before continuing onward. If you were actually here, You could theoretically look sideways and see the back of your own head, because the light carrying that image would curve all the way around and return to your eyes. Space itself is no longer behaving the way it does anywhere else we've been on this journey.
We're now approaching the true boundary of TON 618, the event horizon itself. This isn't a physical surface. There's nothing solid to touch or crash into. It's simply the point where gravity becomes so overwhelming that not even light can travel fast enough to escape it. Cross this line, and there is no turning back, no matter what you do, no matter how powerful your engines are. For an object this massive, the event horizon stretches across roughly 780 astronomical units, larger than the entire orbit of Neptune around our sun. We are seconds away from crossing a boundary that nothing in the universe has ever crossed and returned from.
If any object crossed this boundary, it wouldn't happen gently. The difference in gravitational pull between the near side and far side of an object becomes so extreme that it gets stretched, pulled apart along its length while being compressed from the sides, until it's reduced to a thin stream of particles. Astrophysicists actually call this process spaghettification, and it isn't just theoretical. Around supermassive black holes like TON 618, we've observed exactly this happening to real stars, torn apart in events called tidal disruptions, their remains lighting up briefly before vanishing forever. Nothing that gets this close retains its original shape for very long.
Now imagine we're the ones crossing that line. As we pass the event horizon, something strange happens. We wouldn't feel any sudden impact, no dramatic moment of crossing. From our own perspective, the transition would feel completely smooth, almost unremarkable. But from the outside, something very different would appear to happen. To a distant observer watching us fall, we would appear to slow down more and more, our light stretching and dimming, until we seemed to freeze at the boundary forever, fading slowly into darkness. Two completely different realities happening at the exact same moment, depending entirely on where you're standing to watch.
So what would actually be the last thing you'd see in those final moments before crossing? Not darkness, at least not right away, because light bends so extremely this close to the black hole, the entire universe behind you would appear to warp and compress into a single bright ring wrapped around the edge of the horizon. Every star, every galaxy you've ever seen, folded into one final glowing halo surrounding an absolute void. It would be, quite literally, the last image of the entire universe, compressed into a single circle of light, right before everything goes silent.
But here's the twist we mentioned earlier. Everything we just witnessed happened 10.4 billion years ago. The light carrying that image has been traveling toward us this entire time. TON 618, as it exists today, could look completely different. Some astronomers believe supermassive black holes like this eventually run out of nearby material to consume, entering a quiet, dormant phase where the blazing accretion disk fades away entirely. It's possible that the version of TON 618 blazing across our telescopes right now doesn't actually exist anymore, that somewhere out there it's already gone dark, sitting silently in the depths of a galaxy we'll never get to see as it truly is today.
We traveled 10.4 billion light years to witness one of the most extreme objects the universe has ever created. And the truth is, we still don't fully understand it. What we do know is this: nothing about TON 618 poses any threat to us. It's unimaginably distant, and even light itself needs billions of years just to make the trip. But studying objects like this teaches us something deeper about the universe we live in, its scale, its age, and just how small our entire existence really is within it.